All right, so on that last one, you had. There we go. You had sine theta plus sine squared theta over cosine theta minus tangent theta is secant theta minus cosine theta. That one? Yeah. Which side did you work with to start with? Yeah, Matt.
Right.
You worked with the right?
Yeah.
Really? Okay. It's not the one I would have worked with. Okay. What's that? Sure.
Cool.
Okay.
Well, I actually simplified the left side first.
Oh, so you did a meet in the middle approach.
Yeah, I guess.
So you worked on left side and worked on the right side and showed that they had to be the same thing?
Yeah, so
Okay.
I knew that, or like the left side was, I don't know, I guess more complex, but I knew that tangent had the same common denominator.
Okay.
So I canceled the sines, and then I had sine squared theta over cosine theta.
Okay, so let's do that first. All right, I like that idea. So you start with the left, you rewrote your tangent as sine over cosine? Good, okay, cool. So basically what you're trying to do is combine the two fractions together, like you said. Good. So, and you notice that the cosines were the same. Wonderful. So when you combine your common denominator, or you combine your fractions, I mean, you've got sine of theta plus sine squared theta minus sine of theta. Did you already turn in your worksheet, or do you have it?
It was at school.
Oh, I got you. Okay. So, and then notice that your sines cancel, right? Okay. So we're at sine squared theta over cosine theta.
Yeah. And then, so that's what I had on the left side.
Okay.
And then to the right side, I knew that secant is 1 over cosine.
Okay, so you went to the right-hand side. Okay.
Then I multiplied the cosine theta, or I tried getting a common denominator.
Okay.
So I multiplied the cosine by cosine over cosine.
Okay.
So then, you could turn that into one fraction. So then you get 1 minus cosine squared theta over cosine theta.
Okay.
And then that's sine squared over.
All right, so you, again, on the right-hand side, you notice that the secant was 1 over cosine and got your common denominator. So just going through that process, after you get your common denominator, multiply your second term by the cosine over cosine, and combine, you get the 1 minus cosine squared over cosine, which, like you said, does simplify to sine squared over cosine. And you really do have the two pieces match. So they have to be the same. Yeah, that works, absolutely. If you didn't think about moving on, going to the right-hand side.
So if you got all the way to the sine squared over cosine theta, how many points would you get? I got that. I didn't get to the other.
Okay, so if you get to this point, let's talk about if you got to this point.
That's
here.
like half a point.
It's most of the problem.
Okay.
So if I go from here, say you didn't think about doing this part, but you got to here. Let's look at this sine square. This is one of the things I want to emphasize is these are one of the things that you should start to realize what you can substitute in for. Because what can I replace the sine squared with? The 1 minus cosine squared, right? And then now I've got a minus sign up in my numerator, so I can split this into two pieces. You can split this up as 1 over cosine theta minus cosine squared theta over cosine theta. It's basically doing your common denominator in reverse, right? I'm splitting it up on top into two pieces. 1 over cosine theta is equal to secant, and then here you get a cosine that cancels. So like I said, you were close to being done. Yeah. you were really, really close. But getting used to getting a substitution of sine squared is 1 minus cosine squared. Yeah. So I want to go back to that part and emphasize on that. So, like I think you were really close. You get to that sine squared over cosine, you've got most of the battle done, technically. Questions on this one? Or any other one? Before we go on to new stuff? All right, so we had some new identities to learn today, and I don't like giving you new identities without showing you at least where they come from. So we're going to work through one side of this to show you where one of the identities comes from. The back side of the worksheet shows you where the other one comes from. Now I'm going to go through one side of this. All right, so I want to look at the side that's labeled number 1 at the bottom. Okay, so here's the picture that's at the top of the page. They tell you in the problem that this side AD here is 1. They also tell you that the side AC is 1, but that's actually more for the second page rather than this one. So really, I just need that the AD here is 1. All right, our goal here, even though it doesn't necessarily look like it from this picture, our goal here is to get a formula for the cosine of alpha plus beta. So that's what these questions are leading us through to help us get to that point. So the first part says that in terms of the alpha and beta that are labeled in the picture, what is the measure of this angle DAG in terms of alpha and beta? What does this whole thing have to be? Alpha plus beta, right? Because it's just one on top of the other? Agree? All right, so this has to be alpha plus beta here. Okay. So the second part here says that, okay, I know this whole angle here is alpha plus beta. And the second part asks you, what is this length here, right? Trying to figure out what this is. So the idea here is that if I know alpha plus beta, if I know what this angle is, and I know what this side is here, which I do, I told you that it's 1, how can I figure out what this length is? If I know the angle, and I know this side, how can I figure out this side? Cosine, right? Because notice we have a big right triangle here, don't we? Okay. So how would I use cosine to figure out that side? What would be my relationship that I would write down in terms of cosine?
Alpha plus beta equals to x over 1.
Okay, so if I call that x, it would be x over 1. No, x over 1 is just x, right? We agree? All right. So using that one right triangle that we have here, using this one right triangle I have here, I've got this length of this side is cosine of alpha plus beta. So now we're going to use a couple of other right triangles that we see in the picture to get this cosine of alpha plus beta in terms of some other sides and get a formula for it. It's the idea. And then we're going to talk about how we use the formula to solve different problems. But I just wanted to show you, give you an idea of where the formula comes from. At least one way to figure out where the formula comes from. All right, so our first goal here, notice that I've got this whole long side here, this DB and DE. We're going to break it into a couple of pieces to help us figure out this length and then figure out what the length of these pieces are here. All right, so let's look at some of these other right triangles. Let's look at the question number 3 here. It says in terms of beta, so the beta is right here. Here's beta. It says in terms of the beta, what is this length of AF, which is this length, and DF, which is this length. So notice that we're using another right triangle, right? Okay. Let's look at DF first. Let's say we called this Y. If I wanted to figure out what Y is, what trig function would I use? We would use sine, right? Why would you use sine? If we know beta, why would we use sine? What do we know relative to beta? Opposite and hypotenuse, right? Okay. So what would be the formula we would write down?
That's your A plus B, right?
The A plus B is the whole red arc. So we're just looking at the purple arc here.
So that's just B.
That's just beta, yeah. Okay. So what would I write down for my ratio or my equation then? Yeah, sine of beta is y over 1. So y has to be sine of beta. All right, how about this AF piece then? Here. So, okay, so again, relative to the beta and the 1, that's the adjacent side, isn't it? So what would the equation you, so let's just say I have my AF is Z. Say I call it Z. What would you write down for your equation then? Yeah, so you would have cosine of beta.
We also use like the AF as the variable.
Yeah, that's fine. Yeah. So Z is cosine of beta. Bless you.
Thank you.
So notice all we've done, I mean, the picture looks funky, but all we've done are use right triangles, correct? Right? So then these are ratios like we've set up before, correct? We know this angle, we know this side, we're trying to figure out this side. That was step 1, right? We know this angle, we know this side, we're trying to figure out this side. That was step 2. We know this angle, we know this side, we know this side. That was step 3. Okay so far? All right. So what's question 4 ask? Question 4 says, let me erase some stuff because I got lots of things going on the screen here. Go back to red. How can I relate this angle here that I just colored in red to this angle up here? It's the same. Good. How'd you get there?
Because the other angle in the triangle should be the same.
Okay. So, what do you know about these two angles here? They're the same, right? Because they're vertical angles, aren't they?
Yeah.
Okay. So this one had to be, if this one's alpha, this one is 90 minus alpha, right? They're complements. So that had to be 90 minus alpha, and these two are complements, so it had to be alpha. Right? Okay. So this one's alpha up here. All right, so let's concentrate on that other triangle up here. You already told me that this is sine of beta right here, correct? For the length of that side? We figured that out from the y here? We agree? Yep. Okay. All right, so now we want to concentrate on this side here. How can I get a handle on what the length of that side is? You know the angle, you know the alpha, and you know the df, the sine of beta part. So how would I get a handle on what I just put with the brace there? What would you need to use? Okay, so I would use the tangent, right? If you did tangent of alpha, what does that have to equal? Again, we're using this triangle up here where I've got the alpha at the top. Yeah, it would be the BF, if you want to use it that way, or call it a different letter, over sine of beta, right? Because again, up here is my alpha. BF, relative to alpha, what side does BF represent? The opposite, right? And this is the adjacent. Right? So I'm just using tangent of alpha as opposite over adjacent. We've done problems like this, right? It's a little bit more confusing because I got lots of letters lying around, but it's the same right triangle relationships that we've talked about. So we can solve this for BF. We have sine of beta, tangent of alpha, right? We agree? Just multiply both sides by sine of beta. All right, we're almost home. Almost, I promise. We already know this whole length, correct? That was cosine of beta. We said our AF was cosine of beta. So if I know the whole length, and I know just this part here that I'm coloring under in black, can we figure out what AB is? If I know the whole thing and the one little piece, how can I figure out what AB is? I just need to subtract them, right? The whole thing is cosine of beta. This little piece is sine of beta tangent alpha, so AB must be cosine of beta minus sine of beta tangent alpha. All we're doing there is just subtracting, correct? Think about it with numbers. If this whole length were 5 and this length were 2, what would you tell me this length is? 3, right? Same concept we're using, isn't it? The whole thing is cosine beta. The small piece here is sine beta tangent alpha, so we're just subtracting. So that's one way to figure out AB. But there's another way to figure out AB. So let me erase some things. We have lots of things going on. What's another way to figure out AB? We could use cosine, couldn't we? Because what do we know? What do we know about this x? What was it?
It's it's cosine beta plus b.
Yeah, it was cosine of the alpha plus b, right? Alpha plus beta, right? So how can I express AB using that? What would we write? Here's my alpha right here. What is this what side is this relative to the alpha? Adjacent, and we want the hypotenuse. So what would we write? Cosine of alpha, cosine of alpha is equal to what?
Cosine beta plus b over.
Just the AB piece, right? This is adjacent, this is hypotenuse, right? Cosine is adjacent over hypotenuse, right? And if we rearrange this equation, then our AB had to be cosine of alpha plus beta over cosine of alpha. Just rearranging, right? Multiply both sides by AB, divide by cosine of alpha. What do we have now? What do we have now? I had two things that are equal to AB, don't I? So okay, what can we say about the two expressions? They're equal to each other, right? I have the same thing, so the two expressions are equal, so we must have cosine of alpha plus beta over cosine of alpha is equal to cosine of beta minus sine beta tangent alpha. So what happens if we solve this for cosine of alpha plus beta? What do I need to do to both sides? Multiply by cosine of alpha, so we get cosine alpha, cosine beta, right? What happens in this term when you multiply it by cosine of alpha? In particular, what's going to happen to this piece right here? It's going to be sine alpha, because what's going to happen with the cosines? They'll cancel, correct? So we're going to get, if I just rearrange it, we'll get sine alpha, sine beta. And this is your sum formula for cosine. This is what you're going to need to remember. Okay? But that's how it comes about. I don't ever like writing things down when I don't at least give you an idea of where it comes from. This is where this formula comes from.
So basically, from this sheet, we need to just know that last.
You just need the last part. Yeah. That's the last part you need. We worked through, going through the right triangle relationships, you've done that stuff before, right? It kind of reinforces that. I know there's a lot of letters, but the concepts were just all using the right triangle relationships for the trig functions. But this is the formula that we want to know. Notice that when you break this, we're going to have one for sine here in a minute as well. Okay. But notice that when you have cosine of alpha plus beta, the sign in the middle is a negative sign, all right? When you have the sum formula for cosine, it's a minus sign in the middle. And then it goes cosine, cosine, sine, sine. So let's see how we can use this formula. So say, for example, you were asked to find the exact value of cosine of 75 degrees. All right, so the whole goal of this, when you're asked to find these exact values for angles that you don't know, like 30, 45, 60, the whole goal is to write it in terms of ones that you do know. Now, as a little bit of a trick, when you're doing these, 45 degrees is typically always going to be involved. Okay? So if I know that 45 degrees, if I know that 45 degrees is going to be involved, what's the other angle that would make up the 45 degrees? 30, right? I can rewrite 75 as 45 plus 30. Now, why would we use these two angles? Do we know the exact value for, say, cosine of 45?
Yes.
And cosine of 30?
Yes.
Yeah, that's why I would have used those two. You could have also used 60 and 15, but do I know cosine or sine of 15 off the top of my head? No. Okay. Could also use 37 and 38. That'd be really not helpful. Okay. That's why we used 45 and 30, because I know the exact value of those two for the cosines and sines. All right, so now let's use the formula. Using the formula, what would I have? Okay. Good. Because in the formula, this is playing the role of alpha, this is playing the role of beta, right? We agree? Okay. What's cosine of 45? Good. And what's cosine of 30? So assume we forget. What's cosine of 30? Good. Sine of 45? Yeah, 1 over root 2. And sine of 30? A half. Good. And I don't care if you get a common denominator. Just leave it. This is fine. I don't care if you simplify it. At that point, you're just doing arithmetic, and I assume at some point in your life you've been tested on arithmetic. And I don't want to know if you haven't at some point in your life been tested on arithmetic. That's okay? That's the idea we can use these sum and difference formulas for. So let me write the other ones down. So we have cosine. I'm just going to rewrite the cosine of alpha plus beta just so for reference here. So that was the one we just had. If we change the sign in the middle to a minus, what do you think is going to happen in the formula, do you think? Yeah, it's going to change to a plus in the middle. The format of the formula is exactly the same. It just changes the sign in the middle to a plus. So as far as cosine goes, it's cosine, cosine, sine, sine. Just remember to flip your sign in the middle. Okay. For sine, now the back side of your worksheet would be the development for sine of alpha plus beta. There's other ways to get at it as well. I'm not going to go through it. If you really want to go through it for funsies, you can do that. That's why I put it on there. All right. For sine of alpha plus beta, you get mixed terms. You get a sine of alpha cosine beta, and you get a sine of beta cosine alpha. They flip, but the sign doesn't flip. So the sign stays the same in the middle. So notice that for each of the formulas, something flips. For cosine, it's the sign in the middle that flips. For sine, it's the actual trig functions that flip. All right, so these are the 4 sum and difference formulas that come up from sine and cosine. We'll do tangent here in a minute. I'll actually go through where tangent comes from. That was not too bad. Actually, these aren't too bad either, because we can use other identities to help us get at these. But I'm not going to go through the derivation. You already sat through one of them, so I'm not going to make you sit through all of them. All right, so these, you'll need to remember these, definitely, as well as the tangent ones we do here in a minute. But let's see if we can do another example using, say, what the sine formula. So let's say I asked you for, find the exact value of, say, let's say sine of negative 5 pi over 12. Yes? Say that again? Sum and difference identities, yeah. Okay, so again, like I mentioned when doing these, a trick is involve 45 degrees. Well, this is written in radians rather than degrees. What's 45 degrees in radians? Pi over 4, right? So let's stick in pi over 4 here and see what I would need to subtract off. I know I need to subtract rather than add because it's a minus sign here, right? I'm trying to get negative 5 pi over 12. Okay. All right. So in terms of twelfths, I've got a pi over 4. In terms of twelfths, how many twelfths is that?
3 pi.
That'd be 3 pi over 12, right? Then we multiply by 3 over 3 to get twelfths. What am I trying to get down to? 5. So how many twelfths would I need to subtract? 8, right? I would need to subtract off an 8 pi over 12. What does that simplify to? Two pi over 3, right? We agree? Do I know sine and cosine of pi over 4? Yep. Do I know sine and cosine of 2 pi over 3?
Yes.
Yeah. Cool. I can do this then. So first thing we'll do is use our difference formula for sine. That's up here that I'm underlining here.
How would we know we use that?
Because it's a minus here. So using that formula, what would I write? Not negative. It's just 2 pi over 3. It's alpha minus beta, so the minus sign's in the formula. Okay, and then minus. Okay, cosine. Thanks. Cosine of pi over 4. Again, the trick to doing these is trying to figure out what the alpha and what the beta are. All right, so now going through these, sine of pi over 4 is 1 over square root of 2. Cosine of 2 pi over 3. Well, the reference angle is pi over 3. Cosine of pi over 3 is, it'd be 1/2. And then what quadrant is 2 pi over 3 in? 2. So it'd be negative, right? Because cosine is negative in quadrant 2. Right? The reference angle is pi over 3. That's why I know the absolute value piece, the actual value, the 1/2, because that's cosine of pi over 3. I know it's negative because 2 pi over 3 here is in quadrant 2. All right, let's go to the next piece. Sine of 2 pi over 3. Well, again, the reference angle is pi over 3. Sine of pi over 3 is square root of 3 over 2. We're in quadrant 2, so is it positive or negative for sine? Positive. So the square root of 3 over 2. And then cosine of pi over 4 is 1 over square root of 2. Yeah.
So we can just leave it like
Oh,
that.
please. Yeah. 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 Just leave it. I don't care if you simplify it. That's what calculators are for. By the way, if you were to simplify it, I don't expect you to simplify it, but if you were to simplify it, what are you going to get, a positive answer or a negative answer? It's going to be negative because this is negative and you're subtracting something, right? So the answer is definitely negative, right? How about negative 5 pi over 12? What quadrant would that be in? Well, if I go all the way this way to negative pi over 2, how many pi over 12s is that? 6. So negative 5 pi over 12 must be in quadrant 4. And sine is negative in quadrant 4. So that makes sense with what we got for our answer. Just a quick little check to make sure that the answer is making sense. Questions on that one? Now, some of the problems in Hawks have you putting them back together. So, say it asked you to find the following. Let's say you were asked to simplify cosine of 123 degrees times cosine of 57 degrees minus sine of 123 degrees cosine of 57 degrees. Oops, that should be sine. Should be cosine, cosine, sine, sine. All right, so when I ask you to simplify something like this, it's asking you to recognize the pattern and which sum or difference formula are you using. since it goes cosine, cosine, sine, sine, is it a cosine summary difference or is it a sine summary difference? It's a cosine, right? Since it goes cosine, cosine, sine, sine, it's a cosine summary difference, correct? Since it's a minus sign in the middle, is it a sum formula or is it a difference formula? It's a sum, right? Because remember the cosine flips the sine, right? So this should be, kicked out my charger. There we go. So this should be cosine of something plus something, right? I know it's cosine because of the format, right? And I know it's a plus sign because there's a minus in the middle. Okay. So what should the first angle be here, do you think? 123. And what should the second angle be? 57. And if you add those two together, you get 180. So let's think about cosine of 180. 180 is around here, correct? So that's kind of one of the special ones. What's cosine of pi? What's cosine of 180? It's -1, yeah. Of course, if you would have typed all that in your calculator, it also would have given you -1. Actually, it's possible your calculator would have some rounding errors, and it might give you -0.9999999.
Why? What is like the reason behind why that be -1?
Why it's -1? So think about, there's a couple of ways that you can think about it. One of the ways is that if I think about just where the coordinate of this point ends up, if I use a radius of 1, well, the coordinate is 1, 0 here. If I rotate it 180 degrees, the coordinate's going to be -1, 0. And I'm following what the x coordinate is for cosine. Because if I think about an angle in general, like this, the x coordinate is the adjacent side to the angle. So if I follow the x coordinate, that's why it's -1 when I end up on the other side. Which is the same reason why up here at 1 for sine, it's 1, is because when I follow the y coordinate becomes 1 when I get up there. That's the idea. This okay?
Yeah.
Okay. Let's talk about the tangent formula real quick. If I want a tangent of alpha plus beta, let's see where the formula comes from. Well, much like what we do with identities, if I don't know where else to start, what should your first step be if you're doing an identity? If I don't know where anything else of how to start the problem, what should your first step be? Changes the sine and cosine, all right? Tangent is equal to sine over cosine. And now I do have a sum formula for each of these, don't I? We agree? Yep. So the top, sine of alpha plus beta is what? How do we write that down?
Sine alpha cosine beta plus sine beta cosine alpha.
Good. And then on bottom, how will we write it down?
Cosine alpha cosine beta sine alpha sine beta.
Good. Now, this would be a perfectly acceptable way to do tangent of alpha plus beta. Now, when they actually write down what they say is the sum formula for tangent, they really like it to involve tangents, right? So we can get tangent by doing a trick. What I'm going to do over here is I'm going to divide top and bottom by cosine alpha cosine beta. I'm just going to show you, I'm showing you where the formula comes from. I don't expect you to reproduce it, the work to get to there. The reason why we choose, notice I'm just multiplying by 1, right? I'm multiplying top and bottom by the same thing, so I'm not changing the fraction. Okay? Notice I'm choosing cosine alpha, cosine beta, basically to make this term a 1 right here when I multiply it through. Okay? So when we distribute everything, I'm going to take this, I'm going to distribute it on the top, here and here. I'm going to distribute it on the bottom, here and here. Okay? So we're going to get sine of alpha cosine beta over cosine alpha cosine beta. That's what I get when I take it to the first term on top, right? The second term will be sine of beta cosine alpha over cosine alpha cosine beta. Bottom, do the exact same thing. So I get cosine alpha cosine beta, cosine over cosine alpha cosine beta. Last term is sine alpha sine beta over cosine alpha cosine beta. I know it's ugly, but things are going to look a little bit better here in a second. Give you a chance to write the rest of that down. So again, all I did here was just distribute over the top and distribute over the bottom and rewrite it as the fractions. Now, hopefully as we get through and simplify this, it'll become a little bit more clear of why we did that. Look at your first term on top. Anything nice happen in the first term on top? The cosine betas go away. You're left with sine alpha over cosine alpha. What's another way to rewrite that? Tangent alpha, right? Right? Anything nice happen in the second term? The cosine alphas go away. You have sine beta over cosine beta. What's another way to rewrite that? Tangent of beta. So the top becomes tangent of alpha plus tangent of beta. This first term, the denominator, is going to simplify to what? 1. We rigged it so it would do that, right? That's exactly what I divided top and bottom by, was that term. How can I rewrite the second term in the denominator? Tangent of alpha times tangent of beta, right? So this is what your sum formula for tangent looks like when you see it written most times. If tangent of alpha plus beta is tangent of alpha plus tangent of beta over 1 minus tangent of alpha times tangent of beta. It's a sum on the top, it's a product on the bottom, and the sign is flipped. When you do the difference formula, it has the same format. You just flip the signs, yep. So it's tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. So that is the sum and difference formulas for tangent. Those are. All right, so again, we would use these to help us find exact values of things that we might not know exact values of. Might use them in identities to demonstrate different identities. We also can do other types of problems like we've talked about in the past. So let's do one more example before we go. And then we'll do more examples, and I'll probably have some worksheet problems to do on Friday as well. So let's do another example. Let's say we know that let's say I know that secant of alpha is, let's say, -5 over 4, and cotangent of beta is, let's say, -8 over 15. If, let's say, alpha is in quadrant 3 and beta is in quadrant 2, what is, let's say, sine of alpha plus beta? The first one says quadrant 3 and the second one says quadrant 2. Sorry. All right, so we'll set these up just like we set up problems like we've done in the past. In the past, though, we've only been given one angle. In this case, we're given 2, right? So I need to draw 2 triangles. I'm going to draw one. Oops. It's not quadrant 3. I'm going to draw one for alpha, and I'm going to draw one for beta. I was told that alpha was in quadrant 3, so I drew a triangle down in quadrant 3. I was given that beta is in quadrant 2, so I draw a triangle down over in quadrant 2. All right, so what are we given about alpha? We're given its secant. If we're given secant, what sides can we label? Oh, yeah. The hypotenuse and adjacent, because secant is 1 over cosine. So the hypotenuse is going to be what? 5, and the adjacent will be -4, right? Remember, the hypotenuse is never a negative value, so it's going to be the adjacent that will be -4. How would we find the other side? It's a 3, 4, 5 triangle. You could use the Pythagorean theorem. In this case, it'll be -3. Why did I put a negative on it? Because it's below. Good. Do you agree? Okay. How about beta? We're given cotangent. What can we label for the cotangent? The opposite and the adjacent, just like tangent, right? What's going to go on the adjacent in this case? -8, because that is the numerator for the cotangent, right? And the opposite's going to be 15. How did I know the 8 was negative, but the 15 was the positive and not the other way around? Because the -8 is going to the left side of the y-axis, right? And the 15's above. Can we figure out the hypotenuse? Yep, it's 17. We want sine of alpha plus beta. The sine formula is sine of alpha cosine beta plus sine of beta cosine alpha, right?
How do you get the how do you know it's not the minus?
I mean, I asked you to find this. Yeah, I literally said find the sine of alpha plus beta. That was how I knew this one. Can I figure out sine of alpha now? What is sine of alpha? -3 over 5, right? We're just reading it from the triangle like we've done before. Cosine of beta? Just reading it from the second triangle over here, right? Sine of beta? Okay. Cosine of alpha? -4 over 5. Do I care if you simplify that? No. I don't. Maybe. I don't know. I haven't tried to put in an answer. Sometimes it does and sometimes it doesn't. I'd try it to see if you can do it without simplifying it. This one wouldn't be too bad doing your calculator, though, because you can type it in and just say to a fraction. So that's the fraction of it. Yep. Okay. Yep. That's what that was for. All right. We'll do more of this next time. Don't forget, you've got your test on Wednesday. Right? Next Wednesday.
Identities and these?
Identities and this, and then the inverse function stuff, too. Yeah. Have a good one.
Chief, I'll see you later in the room, Jay. All right. I got a question.
Yeah.
Audience assigned test right before spring break.
It's not on the Friday.